In today's video, here is a nice problem coming from the Russian mathematics Olympiad edition 2003. Here is the following equation. We have p to the x as a power of p equals y to the 3 plus number 1. So p is a prime, x and y are the natural numbers. Okay, so we are simply going to solve this equation. So you guys, if you are interested and would like to give the try to this problem, pre-get into the solution, go ahead, pause the video when you welcome back to see the solution. Okay, before we get into the solution, I would like to remind you, do not forget to support the channel, like, comments and subscribe. Now let's jump into the solution. Okay, so now I'm simply going to factor out this one since we have the sum of two cubes here. So I get the following. I get p to the x equals y cubed plus number 1, which equals y plus number 1, factor y square minus y plus number 1. Okay, we know the left hand side of this equation is divisible by p, which means the right hand side of this equation must be divisible by p as well. So since p is a prime, which means the GCD of p equals 1 or p itself, which means the right hand side of this equation must be number 1 or p as well. Okay, so I get GCD of these two terms, this one and this one, equals 1 or p. Okay, let's set this one equals d as a GCD. Okay, so we'll have two cases here. What's gonna happen if GCD equals 1, which means one of these is going to take the whole thing, p to the x, the other one is going to take number 1. Both of them are divisible by number 1. Okay, so this is the case number 1. For the second case, GCD equals p, which means both of them are sharing p as a prime, as a divisor, as a common greatest divisor. Okay, so let's go through the case number 1. Case number 1, if GCD of y plus number 1 and capital A, let's call this one as a capital A, equals 1, what does this mean? So this one essentially, this one is going to take two cases as well, because I'm going to name it as a sub case number 1. So sub case number 1, if y plus number 1 is going to take number 1 y, because if y plus number 1 equals 1, the other one is going to take the p to the x. So I'm going to simplify y from number 1 from both sides. I get y equals 0. This is clearly, it's impossible, because the first thing, y as a natural number, it cannot be 0. The second thing, if I'm replacing y with 0 here, I get p to the x equals 1, which is impossible to get a prime equals number 1. Okay, so which means this case doesn't work. Let's move on to the second case, which is sub case number 2. Sub case number 2, if y plus number 1 equals, if y plus number 1 equals 1 doesn't work, which means the other one is going to take number 1, because we have GCD equals 1. So what does mean? This one is going to take the whole thing, p to the x. Okay, so if y square minus y plus number 1 is going to take number 1, we are simply going to simplify number 1 from left and right and take y as a common factor here. So get y factor y minus number 1 equals 0. Since y equals 0 doesn't work, because by previous argument we get y equals 0, didn't work, which means y minus number 1 equals 0, which in the other word y equals 1. Okay, so this one implies y equals 1. Y equals 1 may be a solution. Let's insert it back into the original setup. I get p to the x, which equals 1 cubed, which is 1, plus 1 equals 2. Simply we get x equals 1, which means p as an even prime, we get number 2. Let's write as a pair of the solution here, p equals 2 with x equals 1 with y equals 1. So we are done with this case. Now let's move on to the second case when you have GCD equals p. Okay, in this case I get a greatest common divisor is p for both terms. Okay, which means p is going to divide y plus number 1, and also p is going to divide this term. Okay, because they are sharing p as a common divisor. Now let's go through this one. So which means p divides y plus number 1, also p divides y square minus y plus number 1, according to the divisibility statement. So I get here y plus number 1 is a congruent to 0 mod p. Okay, let's take this number 1 to the right side over the congruence. I get y is a congruent to minus 1 mod p. Okay, now let's square both sides. I get y squared is a congruent to 1 mod p. Now let's write this one on this form. Let's put y square minus y plus number 1. So I get y square minus 1 plus number 1 is a congruent. Y square was congruent to 1, but minus 1, I'm going to replace this one minus 1. I get minus 1 is a congruent to 1 mod b. So I get plus this number 1, which means I get the whole thing is a congruent to 3 mod b. It's more simple. I have two things here. I have this one is a congruent to 3 mod p, keep a remainder 3. When you divide this one by p, keep a remainder 3. Also, I get p divides this term. So I have two things. P divides y square minus y plus number 1. Okay. What you can include from this one? So p divides this one. This one is a congruent to 3 mod p, which means if p divides this term, which means I get here 0 or I get a multiple of p. Since p divides the same term, which means I get here 0 or a multiple of p. Since p is a prime, which means p cannot be divided by 3 except if p equals 3. Okay? So this one is telling us immediately p is going to take number 3 based on this information that I have here. Okay? If p equals 3, I'm going to replace it here. Now let's get rid of this one and value of p and replace it into the original equation and move on to the general case. So previously working on this equation and came up with these nice results. So we have extracted the p as a prime equals 3. So we'll be replaced into the original setup. We came up with these nice results. Okay. So as we working as we working on the case number 2. So with GCD p equals 3. So if you would like to be free and avoid all the headaches, just reduce the equation to the mod something, and then where we have no solutions above that point. So for example, if we know by checking and guessing above x equals 3 we have no solution for this equation, you know, just reduce the equation to mod 27. You find the following reminders. There are reminders that you are going to find out. You will not satisfy this equation, which means we have no solution for which means we have no solution for this equation above that point. So ultimately we'll have a defined set where we have a solution. Okay, now let's do that. So by the way of contradiction, suppose x is super equal to 3. I'm going to reduce the equation to the mod 27. Okay, this one will be 0. Y cubed equals 3 to the x minus number 1. I'm going to reduce this to mod 27. This one will be 0 because x is super equal to 3. So I will have minus 1 mod 27. Okay, so as you go by the chart, you are going to find the following reminders. I'm not going to try the chart, do it yourself because it will have a lot of calculation here. So I will have the following reminders. So you get y to the 3 belongs to this set. Minus 10, minus 8, and 0. I have 1, and 8, and 10. Okay, that's the only reminders that we are going to find, which means we'll have absence of minus number 1 in this set, which means we have no solutions for this equation, which is it's impossible. Implies x must be in this set 1 and 2 only. So it's more simple. Number 1 is not going to be a solution. As you replace x with 3 here, I get 3 minus number 1, which is 2. So get y to the 3, which is 2, is not a perfect cube. Okay, also if you reduce this equation, also you can prove x must be even. It cannot be number 1. Okay, by reducing the equation to the mod 4. So it's more simple. You can prove it in the other way. You get x is a even. If I'm going to reduce the equation to the mod 4, because you know y is a even here, so by replacing y with something here, I get 8 is multiplied by something. This 8 will be divisible by number 4, will have 0 here, so I get a remainder number 1. Here I will have minus 1 to the x is a congruent to 1 mod 4, so which means x is a even. Okay, so which means x equals 1 is not going to work, which means x equals 2 is a solution. X is equals 2. I'm going to take this value of x, insert it here to find y. So I get 9 equals y to the 3 plus number 1. In the other word, I get y cubed equals 9 minus number 1, which is 8, which is 2 cubed, thus y equals 2. So I will have another solution. P equals 3, x equals 2 with y equals 2. Okay, are the only solution for this equation. So by the way, don't forget to hit the subscribe button and support our channel. Thank you for watching. See you next video. Bye.